the CSV portion of this lab. Right now we're going to be discussing this open source Hugging Face data set called OpenOrca, and what it contains is a bunch of IDs, prompts for these models, as well as the questions and responses. So this essentially acts like a checkpoint for language learning models to be able to retrain and reiterate on their pre-existing information. So this CSV would basically be in addition to all of the either custom-made model that we wanted to create, or we can append this to an existing model like Mistral. So basically we're going to be passing this data, splitting it, training and testing based on the questions and the responses, and we are going to be applying NLP algorithms to try and learn from these specific prompts. So the first thing we wanted to do is to actually get this data set, and that is done very simply. If we look here, on data exploration, we can see it's just a matter of 3 different packages. It's PyArrow, Pandas, and then datasets from Hugging Face. So I'm just calling the dataset from Hugging Face specifically, and all I need to do is call the repo name, which is very simple. I pass that as a string, and it loads that dataset very easily. From there, I get a Parquet file. And what I want to do with that Parquet file is I want to read it, but then convert it to a CSV so that it's much easier to read with Pandas. So I convert it to a CSV using a one-liner from Pandas, and then I just get the statistics for it and print those statistics out. And if I run that command, it does take a little bit of time due to the conversion rate of the Parquet to CSV. So that's going to take a little bit of time. However, I just wanted to state that, yeah, it's very, very intuitive and simple, and there wasn't a lot of difficult scraping that needed to be done for this CSV. However, I think it'd be very, very essential for fine-tuning the model in the future.
Hi, so this is the HTML part of the data source. So here is the website I chose. It's 4 types of classification has in machine learning. So our domain of choice is machine learning, and after searching through the web, I think this is a great article to have both for people who have not learned of machine learning, who doesn't have any background, or for people who is looking to learn more. So I use this as a supplementary material. It's open source. Yeah, so it's a supplementary material to the course material that's already included in a machine learning course. So let's take a look at the script that I wrote. Yeah, so I saved this script here in scripts, data exploration, and here are some packages I use. It's Beautiful Soup, a bunch of stuff from Selenium, and Pandas for saving the data to a CSV file. So we use the Gecko driver here, and I created driver and then save the URL as a variable. After I get the URL, I use the WebDriver wait, which I waited for 10 seconds. And this is the ID of the title of the article that I want to scrape. So for this project, I'm only scraping the article's titles like headers and the paragraph. So I'm excluding things such as comments, external links, a bunch of like icons, etc., etc. And if it doesn't work, I'll say timeout. And after I used WebDroid, I put everything into a beautiful soup object. And I try to find the main sidebar container, which is basically everything that's where the article is located at. So I try to find all the headers. So this is where the data format comes in. So I decided to save everything to just CSV. And the first variable is gonna include all the headers. The second variable is gonna be all the paragraphs under that title of the header. And each paragraph is going to be its own item stored in the list. So you will see as it goes on, I have basically I took out all the headings from this place. And then I also created a list that stores all the list of paragraphs. So for each heading, I have its own list for the paragraphs for this specific heading that we're looking at. And I'm looking at all the next siblings. And then if the next sibling is another header, we would just stop there because then we reached another topic. But if it's not, then we know that it's a paragraph under this header. So we will append it to the paragraph and then take extracting the text. And then in the end, we will append that paragraph list for that header into the list of paragraphs. And after that's all done, I basically also extracted the text for like the headers. I then create a data frame, which is titles for all the headers and content for all the paragraphs. And I also printed out the dimensions and the first row of the data frame. And then I saved it to the data folder under classification web CSV. And then I will quit the driver so the website close. Let's run this and see how it goes. So the website will pop up. They'll look for a bit when it's trying to find all the tags that I'm looking for in web in the wait function. Yeah, so here we can see that dimension is 992. So we know that there's nine different topics or 9 different titles, and 2 means there's the title and there's the paragraph feature. In the first row, we can see the first title is tutorial overview, and here is a list of all the paragraphs that's under tutorial overview, and then we see that it's successfully saved to CSV.
Hi, this is Team Talker, and now I'm going to show you how we conduct the data extraction from the PDF file. Firstly, we chose 2 types of PDF file. The first is the syllabus, of course, DSCI 552, and the second is the lecture slide we got from the internet. The reason why we chose 2 types of PDF is because these 2 types of files greatly represent the information a TA will need when assisting the students. So let's firstly run the code. You can see the code is running to extract data from the lecture slide now. And it is finished. Can see the results was generated. The txt file is the extraction of the text from those 2 PDF files. And we can see here the formula was also extracted successfully. And let's take a look at the code. Okay, so in this task, we use two packages. The first is PDF Plumber, and the second is the PyTesseract. And the code also mainly consists of two parts. The first one is the extraction of the syllabus, and the second is the extraction of the lecture slide. As for the syllabus, because the syllabus doesn't contain any images or mathematical formula, so we use PDF Plumber directly to extract the contents. Because PDF Plumber performed better in terms of the plain text extractions than the PyTesseract. So the core coding line here is this method. We use the extract text method to get the plain text and then write the text into the result txt file. And then let's look at the lecture slide extraction. The lecture slides contains a lot of images and mathematical formula, and the PDF Plumber doesn't have the functions to extract contents from them. So we have to use an OCR tool. And in Python, this is PyTesseract. It can extract data and contents from images. And so firstly, we have to use the PDF Plumber to convey the PDF page into images and save the image to be extracted later by the PyTesseract. But before we use PyTesseract, we also do an improvement of the image to improve the quality. So it will have a better performance later in the data extraction part by the PyTesseract. We enhance the contrast and brightness here of the image, and again save them into a certain path. And finally, this is the PyTesseract, the image to string method. We use this method of PyTesseract to convey the image, the information of the image to text, and then again save them into the result file. So this is all we have here for the PDF extraction.